All right, we're back to the toilet or the head again in this video, and I wanted to make sure that it was going to fit with some more accurate measurements. So what I did is I started out is I took the head here and I put a stick down here up to the edge there so that I could then measure from that point all the way over to a corner about here. If we make a straight line over here like this, straight up, then straight across like this, we can measure to a point at about right there, and then measure straight down to here so we can get the height, and then we can also measure the width down here at the base. So that's the measurements that I took, and let me show you what we came up with here. So here's the drawing of the head, kind of looking at it from the front view here, and here's the measuring stick that I used, and we can kind of redraw this in like a trapezoid shape here, and the top all the way across came out to about 18 inches wide, which is roughly 457 millimeters, and the head is 11.5 inches tall, or 292 millimeters, and at the base it is 14 inches wide, or 355 millimeters. Now it curves out, there's an angle here. So what is that angle? Well, that's one of the things that we're going to be calculating, and a very important mnemonic to remember is SOHCAHTOA. This stands for sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So a little bit of trigonometry, we can figure this out. What I did is I took this trapezoid and I redrew it down here, and you can see that by drawing some lines, some dotted lines here, we can turn this part into some right triangles. So what we do is we know that the top is 457, and we know down here it's 355 millimeters. So if you take 457 minus 355, you get a triangle here where the top of that triangle is 102 millimeters. And the height of that triangle is still 292. So what that means is, because we're dealing with, in trigonometry, the angled side of a right triangle, that's always the hypotenuse. And you might say, well, which side is your opposite side and which side is your adjacent side? Well, that depends on which angle you're trying to find. In this case, we're looking for this angle right here. So for this angle, the opposite side is 102, and the side nearest this angle is 292. So with TOA, that's tangent is opposite and adjacent. So what that says is we take 192, that's the opposite, divided by 292, that's the adjacent. That gives us the tangent of that angle. Now, we don't know the angle. So most calculators have like a second function button that you can push. And if you do that, you'll see that the tangent turns into like a tangent minus 1. That's what you use to go backwards. So what you do is you take 102 divided by 292 and then hit your tangent minus 1. You might have to push your second button first. And that'll come out to 19.25 degrees. So we know that this angle right here is 19.25 degrees. Now I also put a note down here, make sure your calculator is using degrees. Scientific calculators also have the ability to work in radians. And if you're working in radians, this is not going to work out the way you expect. So put your calculator in degree mode in order for all this to work out. All right, so the next thing to consider is that the height of the head up here was only 11.5 inches. And most toilets I measured are at around 17.5 inches. So that means that the toilet's actually going to need to sit on a platform. So that's why I drew a platform here. Well, how high is that platform? Well, I just kind of put it at 148 right here. And I did that because 148 plus 292 equals 440. And that is roughly 17.3 inches. So I chose this 148 just to give us a nice round number here of 440 millimeters of total height from the bottom of the platform up to the top of the head. All right, so the next thing we want to know is, will this toilet fit? And it's all going to come down to, will this part down here fit in the bottom of the boat? So the way to work that out is, we know that this is, we just take this same triangle that we drew here, and we can extend it and make another little triangle down here kind of facing the opposite direction. And because this is 19.25 degrees, we know that this is also 19.25 degrees. We know that this is 148. What we don't know is this distance right here. If we can find this distance, then we can subtract that from 355, and we can figure out how wide the base would need to be at the bottom. So again, we use trigonometry, the TOA part of the SOHCAHTOA. And in this case, let me reshift here a little bit. In this case, what we have is, there we go. What we have this time is, because we're dealing with this angle up here, the opposite is the one we want to find, and the adjacent is the 148. So we have opposite over adjacent, so x divided by 148 equals the tangent of 19.25. So if we multiply both sides by 148, the 148s will cancel out on the left side, and we're left with x equals 148 times the tangent of 19.25, and x equals 51.68. So if we round that up to, let's say, 52 millimeters, and we subtract 52 millimeters from 355 millimeters, we end up with a base down here of 303 millimeters. So now we know that the top is going to be 457, the bottom of the head is 355, and the bottom of the platform is going to be 303 millimeters wide. Okay, so is all this going to fit on the boat? All right, so to figure that out, we have to look at some drawings. Now, I paid for the plan, so I can't give you all the measurements, but we'll talk a little bit about this. The plans talk about the keel, and the keel is the very bottom of the boat. And at the point where we're interested in, the keel is 266 millimeters wide. So here is looking at the side. You can see that the keel is down at the very bottom, but the toilet doesn't sit right on the keel. There's the floor, or the sole, which is raised up above the keel. All right, so what does the hull look like from the side? And on this boat, one side is perfectly straight, and the other side is angled at 20-degree angle. Now that's good, because this is a 20-degree angle, and we already figured out over here that our toilet is working at about a 19.25-degree angle. They're very close. All right, so we know the very bottom is 266, and how high, what is the width of the sole here? Well, that depends on how high it is. The higher it gets with this angle, the wider we're going to have. So according to the plans, the sole is 248 millimeters above the keel. And what we need to figure out is this little bit right here. So we've got another triangle. We've got an unknown. We've got 248, and we know we've got a 20-degree angle. We work all of that out just like we did before, and we get x at 90.26. So what we can do is we can take 90, add it onto the 266, and we end up with 356. So that means that we've got 356 millimeters width at the sole, and we only need 303. So this toilet is definitely going to fit.